Hello there, my name is Manfred Sommers. I've got over a decade's experience as a high school maths teacher. I've taught the South African maths curriculum, I've taught the British International maths curriculum, and I have taught children across the board from late primary school to school leaver certificate, specifically in mathematics. I have also recorded a short lesson, which I have video lesson, which I've done just to give you an idea of what my teaching is like.
Hello and welcome to our series on matric maths. Today we're going to be dealing with sequences, and more specifically we're going to have a look at arithmetic, geometric and quadratic progressions. Now, the words sequences and progressions are synonymous and they can be used interchangeably. Let's start by having a look at an arithmetic sequence. Right, an arithmetic sequence is created by adding a constant difference. So let's have a look at this example here. We've got the arithmetic sequence 2, 5, 8, and 11. So to get from the first terms to the second term, we added 3. Then to get from the second term, to get from 5 to 8, we also added 3. So you are adding 3 to get to the next term in each case. So this is an arithmetic sequence with the difference. We use that variable d for difference with a constant difference of 3. Term 1 is equal to 2, so we can say a is equal to 2. A is the variable that we use for the first term. So let's have a look at the general term of an arithmetic sequence. The general term is Tn is equal to a plus n minus 1d. And if we want to find the general term of this specific sequence, we're going to substitute in the values of a and d. So a, which was the value of the first term, is 2, and d, which was the value of the constant difference, is 3. Now from here we're going to simplify things a little bit by using the distributive property and multiplying the 3 into the brackets. So we end up now with 2 plus 3n minus 3. And from here we can add the like terms to simplify, and we get the general term Tn is equal to 3n minus 1. Now let's have a look at a geometric sequence. A geometric sequence is created by multiplying through by a constant ratio, or r as we call it. Here's an example. First term 2, second term 6, third term 18, and term 4, 54. So what we did to get from the first term to the second term was we multiplied through by 3. Multiply that by 3 again and you get to the third term, 18, and if you multiply that by 3, you then get to the fourth term, 54. So this is an example of a geometric sequence with r equal to 3. That's because the constant ratio is 3. So term 1 is equal to 2, and we can therefore say a is equal to 2. Now the general term here, or the general term of a geometric sequence, is Tn is equal to a times r to the power of n minus 1. So to work out the general term for this specific sequence, we are going to substitute 2 in for a and 3 in for r. So we now get Tn is equal to 2 times 3 to the power of n minus 1. Okay, and now what we can do is we can use our knowledge of exponents to simplify this a little bit. So we've got 2 times 3 to the power of n times 3 to the minus 1. And we can write this as Tn is equal to 2/3 times 3 to the power of n.